In this problem, tide removes sand from Sandy Point Beach at a rate modeled by the function r. So r of t gives us the rate at which sand is being removed from the beach. A pumping station adds sand to the beach at a rate modeled by the function s. So s of t gives us the rate at which sand is being added to the beach. Both of these are rates, which means both of them are derivatives, even though you don't see the r prime and the s prime. Both r of t and s of t have units of cubic yards per hour, and t is measured in hours from 0 to 6. And at time t equals 0, the beach contains 2,500 cubic yards of sand. How much sand will the tide remove from the beach during this 6-hour period? Indicate units of measure. So the first thing I'm going to do is enter these two functions, r of t and y1, s of t and y2. Now what I'm asked here is how much sand is the tide removing from the beach over the 6-hour period. And that's simply the integral expression, integral from 0 to 6 of r of t dt. To do this, I'm going to use fn int. So go back to the main screen, math. Fn int is option 9, vars, y vars. I want the removing, so I want y1, function, y1, comma x, the variable of integration, and my limits of integration are going to be from 0 to 6, close parentheses, and I get 31.816 rounded to 3 places. And the units there, since it's sand, is yards cubed, or cubic yards. Second, write an expression y of t for the total number of cubic yards of sand on the beach at time t. Well, for this we need to consider 3 things. We need to consider the amount of sand that's there at the beginning, how much sand has been removed up to a particular time t, and how much sand has been added up to that time t. So we start with the initial amount of sand, which is 2,500 cubic yards, and then the amount of sand that's added up to a time t is given by the integral from 0 to t of s of x dx. So remember that since t is our independent variable, we can't use t in the integrand, and in the variable of integration we use a dummy variable there. So now we have the initial amount of sand and we have the sand that's added. We also need to account for the sand that's been taken away. And so we would have, we want to subtract the integral from 0 to t of r of x dx. Why are we subtracting? Well, if you note above that the tide removing sand from 0 to 6 gave us a positive quantity. That's the amount of sand that was removed. So we have to really subtract that quantity. Putting this all together and simplifying a bit, we can write that y of t is equal to 2,500 plus the integral from 0 to t of s of x minus r of x dx. And that's part B. For part C, it asks find the rate at which the total amount of sand on the beach is changing at time t equals 4. Well, the total amount of sand on the beach is given by y of t, and the rate at which that amount is changing is going to be y prime of t. And so that is the derivative of 2,500 plus integral from 0 to t s of x minus r of x dx. And by the second part of the fundamental theorem of calculus, that whole thing just comes down to being s of t minus r of t, which really makes sense because the rate at which the amount of sand on the beach is changing has nothing to do with how much sand is there. It's just based on how much is being added at a time minus how much is being subtracted at a time. If it's being added faster than it's being taken away, then this will be positive. If it's being taken away faster than it's being added, then it will be negative. And in this case, we're trying to determine this at time t equals 4. Well, right now we don't have a function in the calculator for y prime of t. That's just s of t minus r of t, which would be y2 minus y1. So I'll put that in. Remember that that's y2 minus y1. And all I need to do is evaluate that function at 4. So I go back to the main screen, vars, y vars, function, y3 at 4, and I get negative 1.909 rounded to 3 decimal places.